Galilean relativity. You've just started the recording, okay. One would have an ideal relativity for uniformly moving objects. But once you have this medium, say air, as I say in the case of sound transmission, or in the case generally of dynamics or mechanics, you have a frame of reference. Similarly, for electromagnetic radiation, if you didn't have any ether, if you did have an absolute vacuum, well, then the principle of relativity for uniformly moving objects would be true. But this ether gives you a frame of reference. So that's one thing. We possibly could tease that out a little more. And the second thing that just occurred to me as I was just looking at some of the papers in the last week or so was the Newtonian derivation for the deflection of light passing through a gravitational field. For example, the classic experiments where the light, which is moving across the sun's limb, is deflected, and the Newtonian value is half the Einsteinian value. And I think we've probably discussed before that the experimental evidence is not very convincing as to which is true. I mean, the 1919 Eddington exhibition, which claimed to prove that Einstein was right and Newton was wrong, doesn't seem to be convincing at all if you analyze it in detail. But we could talk maybe briefly about how the Newtonian principle comes in. It sort of considers light to a certain extent as corpuscles. So there's just some ideas you might wish to include.
Okay, so what was the you discussed the existence or non-existence of an ether compared with Aristotelian compared to Newtonian. So were you saying is that is there a problem with that? Which one do you prefer?
Sorry, I unfortunately left the conference there, but you got me back. Is there a problem? Which one I prefer? Well, I mean, I think you yourself summarized the talk where you were looking at Aristotle, saying that sort of the Newtonian system is an idealized system, and the Aristotelian system is, I suppose, what we experience in everyday life. So we might, just have a look at that. In that the ether, if you like, is almost undetectable. But if you do some very, very careful experiments, you perhaps detect something which is best explained in terms of ether. The other one is,
is there anyone here who would strongly defend the notion that there is no such ether or that it is completely unnecessary? Would someone like to represent that viewpoint so we can have a little debate?
That's easy. There's no evidence for any kind of an ether, but that depends on what you mean by ether. What do you mean exactly? I mean, this is just an ambiguous kind of argument. The real issue in my mind is how can you explain the fact that the motion of the Earth around the sun, if it exists, is undetectable? But you have experiments that say, okay, we can look out into the sky and we can see the stars moving around with the motion of the sun, but we can't detect that motion with detectors on the Earth. We have to look beyond the Earth to be able to detect the motion. And basically what science has done is they've cooked up this kind of fudge theory called relativity, special relativity, that doesn't really explain it, but pretends to explain it. And that's really the issue. It's not really a question of whether there's an ether or not. It's how do you resolve this experimental conflict?
Well, that's a little bit hard to. So it's like if I asked you point blank whether you thought the ether exists, your answer is it's not relevant. Is that accurate? Or would you strongly say, no, there's absolutely no ether, and argue it that way? I'm looking for a no etherist. Harry, you still there? Something might have happened here.
I agree that special relativity is just really a quick fix, an attempted quick fix. I agree with Harry on that, but Harry seems to be coming to one conclusion, which is the same as the special theory of relativity, and that is that the ether is unnecessary. It's an unnecessary hypothesis. Whereas I would maintain that it is really the simplest explanation, and that rather than go into all the conundrum of special relativity that you've maybe hinted at there, I would say that the entrainment of this medium, the entrainment of the ether, if you like, analogously to the entrainment of air or the atmosphere on the Earth, is basically responsible for the non-detection or the non-detection of the majority of the case of the relative motion of the Earth and the.
All right. Well, what do you mean when you use the word ether? That's really the key point. What do you really mean? I mean, I could use the word and put a completely different interpretation on it than what you put on it. So I think that, and a lot of people are trying to invent things like pola and I mean, that doesn't work. I mean, none of these ideas that people are talking about really work as far as I'm going to explain electromagnetic radiation by some kind of material ether. That just doesn't work.
Well, I think a lot of people have tried, and they would certainly disagree with you on that point. So, of course, all of that is.
Have you been following the email discussions that have been going on? I mean, all it is goes round in circles.
Well, I was just about to say that, Harry. I mean, it pains me to see all these email discussions. I mean, there are thousands and thousands and thousands and thousands of words going out about what it might be and what it might not be. So when you ask me that question, I'm very cautious. I think I've said this before. I mean, all I'm postulating is something which is responsible for properties which we can repeatedly measure, such as the impedance of free space, if you like, 377 ohms, and the electric permittivity and the magnetic permeability, and indeed the speed of light. I'm just talking about a medium which has those properties. But I agree that all this carry on is really it's prejudging the situation. You could just talk forever.
Well, I think I would accept a view that if you just tell me ether is what we refer to when we talk about the properties of space, that would be okay to me. But most people, want to define it as something that exists in space in addition to space, and it's hidden, and we can't really detect it, but it's really there, although we can't detect it, but it must be there because we say so. To me, that's just not getting anywhere. I could see why mainstream has sort of done what they've done, which is they've sort of buried the problem by essentially saying, well, special relativity is right, relativity is correct. And then that's just creating another set of obscure problems. But by holding on to that, they sort of essentially make the real problem disappear. And so they don't have to deal with it, which I think is basically what they've done. They've essentially swept the problem under the rug.
Well, I think as dissidents, though, we need to stop sweeping we need to be less cautious, I suppose. People just need to take a frickin' stand, I think, and argue
stand on what
or the other. Whether their logic is really correct, because that's all we're seeing is that in the dissident community, we just see kind of people just constantly repeating their stance. But what you really need is you need to have two of these people who have opposite stances and have them debate and actually have one person change the other person's mind one way or the other. Now, I don't know if that's ever going to happen. But, for example, I would take very strong stances on the ether being a positron electron C or something like that. And I would say that the reason why you should believe that is because it explains certain things like the propagation of light through that medium. It's been, you can calculate what that speed would be based on the known properties of electrons and positrons, and it turns out to be, say, the speed of light. Also, the permittivity and permeability can be predicted based upon that model, and those aren't my calculations. That's like the EPOLA models. There's a lot of empirical evidence that can be explained by that particular model. So, I would put arguments out like that, which would seem to be.
Yeah, but you say that light is a longitudinal wave in your theory, and there's no evidence to support that. So whatever theory you come up with has to be consistent with the facts of experiment. And really, basically, what I think is that what mainstream does is they kind of come up with a theory that fits the facts of experiments as closely as they can. But when you examine it, it doesn't really fit everything really perfectly. There's, these bad contradictions that they sweep aside. And so, but your theory has some glaring ones.
I don't think it has any glaring ones. I'd be happy to.
I just told you it.
Debate what the glaring.
I just told you what it was.
Okay, for example, give me one.
Your theory is a longitudinal wave of light. Light is not a longitudinal wave.
And what evidence do you have that it's not a longitudinal wave?
Just look at a physics book.
There's nothing in
We've had this discussion over and over and over again. I'm just pointing out that your theory has that flaw. Okay, your theory has that critically terrible flaw.
No, it doesn't. Harry,
hold on.
Not have that flaw at all.
Hold on. All these other theories that people have been talking about also have this same flaw, which is they try to create some kind of medium through which electromagnetic waves move, and the problem is that you have longitudinal and transverse vibrations, and they're coupled. And so how do you make it so that your medium doesn't have a longitudinal vibration but only has a transverse vibration? Nobody's really solved that problem. So this whole idea of making hold on. So this whole idea of trying to make an ether a kind of a physical medium through which electromagnetic waves moves isn't really working.
No, that's only because of this polarization argument that's being used to indicate that light has a transverse nature. Now, that actually turns out to be the false thing, because polarization itself does not indicate that the wave is of a transverse nature. All that means is that the light travels as like a bullet, or the light travels as like a particle in particular packets in particular vector directions.
All right, how in your theory do you explain the fact that you can have a right-hand circular and left-hand circular polarization from satellites, and we can transmit messages back and forth from Earth to space on opposite polarizations in your theory? You have to explain that in your theory, and you can't.
Well, you're right there. That's an active area of investigation, what right and left polarization means. So
well, you also have to add vertical and horizontal, because they also use vertical and horizontal. So you can use either left hand or right hand. Okay, the international satellites like Intelsat uses left hand and right hand, and the domestic satellites use vertical and horizontal.
Okay, I'll give you that one, Eric. But that is only one. So that's one particular area that I would need to investigate. Now, I do see we have some flags here, so I'm going to let some other people talk. So, Michael and Chesky, I think you had your flag up first.
Well, if there's an ether, it has to be universal. The only original universal substrate would have been space itself, which means if ether is derived from space and it's universal, it would be massless. So this causes it's counterintuitive in our experience, where we have solid bodies we deal with every day. But that's the only thing that makes sense for an ether. How it could have come about, how it could have arisen. my model of the ether says that light is the light that we observe of photons is built up by the ether units, which are elemental and universal and act linearly, vibrationally, by vibratory contact between identical elemental units, perfectly linear. And that
so how does this ether that you're talking about transmit photons? First off, you have to tell me what a photon is. Excuse me. First, you have to tell me what a photon is, and you haven't. And the second thing is you have to tell me what these ether units are and how they transmit photons.
Photons or electrons are generated along the path of the transmission by the elemental units, because the elemental units are universal. They are a continuum, and everything from then on was including quantum units are made of these elemental ether units. And the dynamics of the ether units is vibrational, and that's why we have so much trouble detecting an ether, because its dynamics are different.
How does an ether unit vibrate?
What is an ether unit? I mean, this is your fundamental problem. I mean, I agree with Harry that, what is this ether unit? How can we know what properties it has? Or, if we don't know what that thing is, how do we know it can vibrate? What causes it to vibrate?
It's logically, it's the only thing that a way it could have arisen would have been from a universal oscillation, which transitioned to a universal vibration.
No, that's not. I mean, I just want to let you know that when you say this is the only way it has to arise from a universal oscillation, no. Most people, when you say that, I'm just saying, and out of all due respect, that is going right over people's head and is going, what? Because no, that is definitely not the only way it can happen.
Well, there's no other way that anybody can say. I mean, it's the only logical possible.
No, I'm just saying, there's no logic in that statement.
Well, otherwise you just have to say, well, there's an ether and it's a medium, and we're trying to detect it by measuring quantum dynamics.
No, see, that's not true. In stark contrast, say the Ebola. It's not my theory, but they say space is filled with an electron, positron, lattice, much like salt. So that's definite physical manifestation of the ether. So that's an example where clearly your theory is not the only alternative, right? There's, the Ebola people would definitely say there are alternatives other than just saying it's the ether, right?
Well, you could take quantum entanglement. The only possible model for quantum entanglement, in my opinion, is a perfectly linear transmission of identical units having direct contact, direct vibratory contact with each other, and making a perfect connection between quantum units, which are built up of these same elemental units, which retain their vibratory capability, even though they are quantum units and have their own dynamics. They also have this other dynamic because
all you're saying there is that they're connected by something. Now that could be a steel rod, for all we know, but definitely there are other other alternative explanations for quantum entanglement. The one that I most prefer is that if I take my right hand and I take my left hand and I take my right hand and I cut it off and I put it into Boston, and then when they open up the box in Boston, they see that's the right hand, therefore the one that's in Seattle must be the left hand. And that is what entanglement is.
Yes, but they have demonstrated ongoing connections, dynamic connections between the units that
they haven't.
Occurring at the time of measurement.
I would challenge you to find me any experiment in a quantum entanglement where they say that, if there's a left and a right, that they change this one to a left and it causes the right one over here to change to left. That would be actual communication, but that is never done. You'll see that in any quantum communications experiment, they start out with the quantums in the same location, and then they send one out to one place and they send another one out to another place. And yes, they are highly correlated. This is the whole thing. Quantum entanglement is about correlation.
They're
right?
dynamically correlated. They're dynamically correlated because outside
They are not
influences are
dynamically
projected onto the
correlated.
units, and there's a connection demonstrated, which can only occur by dynamic transition of the units after separation.
No, I've looked at these experiments, and definitely, they're just what is called a correlation, which is that whenever they find a right someplace, they'll find a left in the other. And why is that? Because they started out together, and it only produced the left and the right. And when you measure the right, it'll obviously, the other thing coming out is going to be the left. There is never any actual communication going on. You can't take one of these quantum entangled particles, specifically turn it to a different value. I mean, how would you do that? I mean, they're measuring things like spin. You can't turn the spin of an electron from up to down. At least that's what you would have to do in order to show that the spin of another electron 3 miles away went from up to down, right? Now, they just can't show that.
Well, that's the Franklin-Hugh model of quantum entanglement, but I don't think that's the majority opinion.
No, let's see, this is why you have to understand it and explain it. And this is why I think people need to take a specific stand. Because I would say that, yeah, I've studied those experiments. Every single one that I've looked at has to do with this correlation. And this correlation is just a bunch of BS. And I think if you even actually ask the people in mainstream what's going on, that they would say, yeah, there's no actual communication going on here. But what they're getting is this correlation, which is not a very interesting thing because it's just this whole right glove, left glove thing.
Well, can I just give a brief so-called quantum entanglement just represents radiated packets of etheric energy which have the same vibratory pattern. Elemental etheric units are the only actual participants in the phenomenon, and the quantum units are kinetically walled off. And it's all part of the quiet, purring, universal ether mechanism.
So is your theory similar to Bohm's theory? Is that what you're saying?
I don't know that theory.
All right. Sounded
similar. What do you think of that, Harry? I mean, or Bob, you've just raised your hand. I want to know what you think of Michael Antesky's theory. Now, to me, that was just a bunch of words that mean almost nothing to me. It's highly unconvincing, in my opinion. But Bob, I want to know what you think.
Well, I don't have a strong opinion one way or another on that. I was going to say earlier, what would be interesting is the experiments showing the one-way speed of light is not symmetrical or not isotropic. And I also want to mention to Harry about the longitudinal versus transverse waves, maybe in light, but in things that are know if light is the same as an electromagnetic wave. An electromagnetic wave, I think I can show very easily that it's a longitudinal wave, not a transverse wave. And I'd love to show these diagrams and get people's feedback, because I'm building up a presentation for a conference, and I'd love to have the feedback to see if I'm completely wrong, or if, yeah, I can.
How do you explain circular, right hand, left hand, and linear, and right and left?
Quadrature.
Horizontal and vertical. How do you explain that?
Yeah, I'll show you. Can I share my screen?
Yeah, I can promote you if you've got it. Let me see here. Where are you? Okay, you've been promoted, so you can go down in the share and share your screen, and we'll be able to see what you're looking at.
Let's see, whiteboard, share screen.
There you, okay, yeah, okay, we can see your screen.
Okay, so these blue dots, let me see, I gotta move you guys over here.
Yeah, move my picture out of the way.
So, can you also see my mouse pointer?
Yes, we can see your mouse pointer.
Okay, so this blue dot is a charge. I haven't flushed.
Well, actually, maybe I can't see your mouse. That was my mouse pointer.
Okay, then let me do this.
There is a, let me see here. Well,
let me do this. So,
okay, I can see that cross. Yeah, we can see that.
so this guy is a charge, and this guy is a charge, and the force, I'm saying, but on this small dot, due to this large dot, these are charged bodies. I'm representing with this big arrow here. Okay, and I'm saying that this charge is initially at a coordinate origin. So there is a force due to this charge at the origin on this charge, and I'm just pointing it in this direction. It has some magnitude. Divide by the charge, that's your electric field at that point. Move the charge to this position, that electric field increases in the direction of the motion of this charge. Make that charge further away, and that electric field decreases. Do that continuously in an oscillatory way. At this point, you have a longitudinal electric field. Make it far enough away so that there's time delays. You're talking about a longitudinal electric field. Now, is there something wrong with that quote-unquote demonstration? Because if there is, I need to know it before I get up in front of a couple of hundred people and advocate for longitudinal waves and electrodynamics.
Well, I would say that it's kind of longitudinal, but you're just talking about the time-varying electric field. If you take a slowly, if you like you're demonstrating there, if you take a charge and you move it slowly away, and then you bring it slowly back in, I mean, you'll get, if you put any kind of charge meter on it, you'll see the value go up and the value go down.
Right.
And
not necessarily agree with the quote-unquote slow, because I'm thinking radio waves in particular. And so that's just the first part. Is it possible that there are any longitudinal waves in electrodynamics? And I think this shows, yes, it's possible. Then if you go...
Well, hold on, Bob. Basically what you have is a static field case. And you're not dealing with oscillating waves per se, radio waves. I mean, it's not a radio wave. You've got a static field there.
But the charge is moving. It's not just discrete points. I'm suggesting that as this charge, if I can select, as this charge moves closer continuously and oscillates back and then oscillates forward and back, what are you going to see remotely at this point? You're going to see an oscillating electric field in the direction of the motion. That's longitudinal waves. That's just for one point. That's not for a collection of charges in an antenna. And I'll show that next on the next slide.
Go ahead.
But just quickly, it's an oscillating electrostatic field. And the electrostatic field, as far as we know, travels at a speed which is orders of magnitude greater than the speed of light. So it's longitudinal, but it's quite a different animal. Those are my comments, anyway.
I would love to understand your comment in that. Do you have a reference that shows that I could use that shows that the electrostatic field travels much faster than that of light? And I'm not sure what the other point, I just lost the other point. Because I've never heard that before.
Yeah, I'll have to see, could I get something, because I'm looking at both gravitational fields and electrostatic fields, which seem to indicate their presence at almost instantaneously, maybe orders of magnitude greater than the speed of light. I'll see, can I find something from electrostatic? I'm not sure if I have it at present.
Okay. The other comment I need to make is people should know that I'm very much into Weber electrodynamics. And so this is coming from a Weber electrodynamics point of view, which when I go to my next screen, which is only partially done again, on the left here, I have an antenna in this direction. So there's lots of charges in this antenna oscillating. they never move the whole length of an antenna, of course. They're just oscillating a little bit here, and they oscillate a little bit here, you know, all along this antenna. I'm just showing two charges in that antenna. If you look at Weber electrodynamics, it says that a point out here, a charge point out here, will feel a force in the direction connecting this charge and the source charge in the antenna along this line. And so if you do this, come on, trying to do this real time. There's another force due to the other charge, paste, which is in this direction due to this charge. If you add those two vectors up, you get a net vector, which is in this direction, and that is the linear polarization and supposedly transverse direction. So it appears to be a transverse wave, but it isn't. Well, it is and it isn't. If you look at any individual charge in motion in that antenna, it's going to be a longitudinal wave. But if you add up all of the contributions, it turns out that it's mainly in the transverse direction. It's just
that's the wrong direction for radiation from an antenna.
I'm sorry? What was that?
Well, you're saying this vector that you show pointing straight up,
Approximately.
that's parallel to the antenna. Antennas don't radiate parallel to their axis.
Okay.
They don't radiate parallel.
So you're talking about like I can't explain circular polarization, but you have a antenna that's horizontal, and then you'll find that if you have an antenna which is vertical, it doesn't receive that signal very well. It really wants to have a horizontal receiver as well as a transmitter. Right? Is that kind of thing you're talking about there?
I have no idea what he's talking about.
I thought that the direction of the wave is away from the antenna, as in this vector which I just drew, and so the electric wave would be perpendicular to that direction, which is this up axis, but it could be around, going all the way around this vector.
Well, I have no idea
Transverse.
what direction is your wave going in. I thought your wave was going perpendicular. Where's the magnetic field, by the way?
There is no magnetic field in Weber electrodynamics. There is only the electrostatic field, which can be in motion, so the term static really doesn't apply. So in Weber electrodynamics, there is no magnetic field. The force on a test charge body in the environment of an antenna. What is the force on that charge test body, and divide by the overall charge to the electric field? And the force is always along the line joining the source. So it's, that's a source, this is a source, and the force is along that line, which gives you this force, and along this line, which gives you this force. Plus all these other charges, which I'm not showing in the antenna, also oscillating. You add all those up, you get a net force perpendicular to the propagation direction of the wave, the quote-unquote wave. Now for circular polarization, you do this in quadrature. You know what quadrature is?
No, I have no idea.
Okay. So you then...
Well, you can't do circular polarization because you have no magnetic field.
Circular polarization of the electric field vector.
You got no magnetic field. I don't see how you're going to do it.
Because of the electric field polarization, which is shown there.
You're not generating any power. You have no radiated power because you have no magnetic field.
I have radiated power
No,
because
you don't. All you have is a force that you claim exists, but you can't radiate power because you have no magnetic field.
the power is the
That's not
force
necessarily true. I
on
mean,
the
you can radiate
charge per
sound
unit
power,
time.
and there's no magnetic field involved in that. So
There's a force on this test charge particle. Therefore, there's an energy on this test particle. Somebody's going to turn their mic on.
there we go.
So in Weber electrodynamics, there is no magnetic field.
To me, that's just a dead horse right there.
But there is a force on the charge.
Well, I'm sorry. I don't think this is, you're trying to explain something to us based on a theory that we don't know hardly anything about. I just don't see the point.
Well, that's what we
it's
hear
just,
scientists to explore.
I mean, to me, you're saying, oh, I've got this theory that's different than the theory that everybody has used for the last 100 years. And I'm going to explain electromagnetic theory based on a theory that nobody's been using for 100 years. So I don't really see the point.
No, that is the point. That's exactly what we do.
I mean, I don't understand. How can you say there's no magnetic field? To me, that's just doesn't make sense.
Okay, a magnetic field, let me see. You can define it as mathematical, B equal velocity cross product.
I know what a magnetic field is, yeah.
E. 0. So this is the way that a quote-unquote magnetic induction variable parameter quantity is defined in Weber electrodynamics. And I think there's maybe a 1 over C or 1 over C squared or something. But see, that means that it's really the electric static field, which...
So you're saying that the magnetic field is the electrostatic field?
Experienced by a test charge body which is in motion relative to the electrostatic field.
Well, that's just nothing more than the Lorentz law that you've drawn there.
Right, which is why I don't understand why when I say there is no magnetic field in Weber electrodynamics, it's only this electrostatic field in this equation, for example. I don't understand why.
Are we talking about a magnetostatic field or what something else?
The magnetic induction field?
Okay, magnetic, that's B.
Yes.
But you're
Which
just saying
H,
that
by the way, so-
magnetic field only exists because of the fundamental electric field. So therefore,
right.
If you only talk about electric field, then the magnetic field is just another aspect of it, not separate.
You can find this, I think, also in Maxwell electrodynamics. It's not exactly the same equation that I've just put here. And some textbooks say there's problems with this particular equation. And for discrete charges, I think they say there's a problem with this equation. But in Weber electrodynamics, there is no problem with this equation. And so I'm saying that the real field is the electric field, and the magnetic induction fields, or any other quote-unquote magnetic field, is simply the way that a charged body experiences that electric field, and the charged body is in motion. So now there's a relative motion. There's no real magnetic field. It's just the charges in motion relative to each other.
Okay, so how do you explain, magnets?
Charge in motion. Show me a magnet that does not have any charge in motion. And if it still has a magnetic field, then yes, I'd be wrong. But I think
I don't see any charges in motion in a magnet. Sorry.
Well, there's the electrons. The electron.
Now you've introduced another hypothesis.
That there are electrons?
Well,
electrons
I
carry
think
a
you're going to be
magnetic
hard
moment.
pressed to show me that there's electric current in a magnet.
If there's electrons, and then of course you're right, you got to go to some model. What do you mean by an electron? And but whatever that model is, we know from experiments that it carries a magnetic moment. And so the hypothesis is, in a lot of models, I'm not advocating a particular model, but in a lot of models, they're saying that magnetic moment is due to some kind of charge in motion. What that motion is, I don't know.
What about spin, the magnetic spin of an electron? How's that?
Well, that could be a motion. I don't know. All I know is that there's a magnetic moment to the electrons.
Mhm.
Pick a model, and usually that model says, well, if there's a magnetic moment to the electrons, then there's some kind of charge in motion to the electron, but we don't know what the hell that really is.
But as you've said yourself, the same could be applied to Maxwellian electrodynamics, where the magnetic induction is basically caused by relative motion.
Right.
So my understanding is that Weber electrodynamics is not essentially different in this respect. It merely has additional terms dependent upon the velocity, the relative velocity. It's not, that there's no magnetic induction, whereas in Maxwellian electrodynamics there is magnetic induction. They're both the same in that regard. That's the way I'd express it.
Yes.
I'm getting a little bit of echo out of you, Bob, so I may mute you if you're not speaking.
Yeah, but I don't really see how any of this goes to the issue of whether or not there's an ether, and if there is an ether, what is it? What is it? My understanding is Weber electrodynamics makes no hypothesis. In Weber electrodynamics, there's no ether and no need for an ether. Is that not correct?
Franklin talked earlier about dissidents maybe sitting on the fence or something to a certain extent, and I must confess I possibly do that as well. So I wanted to raise another point. I mentioned this ether accounting for the electromagnetic properties of physics, I suppose. But there's another thing that has been raised by a number of people, people like David Toom, I think, have attributed the properties of inertia and maybe things like centrifugal force and Coriolis force to the ether. They were saying if you didn't have an ether, you wouldn't have those things. Now, that's something I haven't accepted, but I have an open mind on it. I'm looking at it for the moment. So in other words, I'm not convinced that the ether has sort of macroscopic effects on matter, which are sort of sensible. We can, I maintain, I think I've written about this, we can measure over large distances the sort of redshift effect because of a sort of a dissipation in the ether. But I'm talking about everyday experiences, that the ether has a sort of a friction, and that the ether stops bodies, moving, or it maintains bodies and it stops bodies from moving off a straight line, and is responsible for Newton's first law. I think David Toom and some other people who look at the properties of ether, and maybe some of the geocentrists, for all I know, hold that view, and I'm not convinced about it at all. I am merely concerned with the electromagnetic properties of the ether, and therefore, to a certain extent, to repeat myself, I do confess that to a certain extent I'm sitting on the fence with regard to this, and I'm being cautious.
Well, that kind of brought up wait a minute, I got one big echo. Like the Foucaults Pendulum, I think we'd call it. You see this in science museums, and you see this big pendulum, and due to the rotation of the Earth, it's knocking over the pins. I'm sure perhaps you've seen that. But to me, that is kind of a demonstration, an overt demonstration of the presence of an ether, which is defining the frame of the Earth as it's spinning. So the only reason why that pendulum is moving around is because the pendulum thinks it's going in a straight line, as defined by the Earth-centered the ECI, Earth's inertial center, frame of reference. Now this goes back to Harry's questions of why is it we can't measure the motion of the Earth through going around the sun, because effectively whatever this ether is, it defines the center of the Earth as being stationary. And that kind of also goes to like geocentric kind of people, because the only way that the Earth can be the center, the non-moving center of the ether bubble is if, I don't know, it could be that the Earth is at the center of the universe, or it could be that our ether is entrained around the Earth such that it's allowed to spin inside of it, but not drag it around with it. See, so that's one of those weird things that you kind of have to accept about the ether, because it really is telling us that the Earth, the center of the Earth, is fixed in space, and if there is an ether, that the ether is fixed to that spot while we're rotating, because we can detect the rotation. Sagnac experiment detects a 24-hour rotation, but doesn't detect the relative motion of the Earth around the sun, or the relative motion of Earth around the universe. So I have to kind of give the geocentrist a nod on that one.
Well, I think we agree about these effects, but I don't talk about the ether as being responsible for the Foucault pendulum. I mean, I talk about an absolute space, if you like, a Newtonian absolute space, and this is responsible for, say, the Newton bucket or the Foucault pendulum experiments. Indeed, it indicates that acceleration in regard to dynamics is not relativistic. There's an absolute acceleration which only the accelerating body will experience. And furthermore, I do conceive that, in other words, the ether is not synonymous with the absolute frame in my book. I do conceive that the ether can move relative to the absolute frame. So you can get a sort of an ether dragging effect. And the ether is only a local absolute frame, if you like. So in most cases, your model and mine agree, because the Earth is within an ether bubble, and its daily rotation is very much less inertial than its yearly rotation around the sun. So the latter is hardly ever detectable. You can hardly detect it. You get a very small, whereas you get the absolute 24-hour effect.
Actually, there have been experiments, first of all, that clearly show the Earth's rotation within the bubble that you're talking about. Like Michelson-Gale and ring laser gyros can detect that motion. So those are, and the GPS as well works with that model too.
Yeah, that's what I was saying. I wasn't disagreeing with that. I was saying there's a non-symmetry, if you like, because it measures the this rotation because of its non-inertial.
Yeah, I'm just saying that there are specific, well-established experimental data that indicates that. It's not just
that would be consistent with the Earth sitting in its own little bubble of ether, which is largely motionless. Although that wouldn't explain why is it that the Earth itself is not motionless within that bubble, that we can detect a 24-hour rotation inside of it. You think if we were dragging a bubble of ether around with us, that the surface of the Earth would probably drag it such that it would rotate with the Earth, but it apparently doesn't. It apparently stays fixed, and the Earth is spinning inside of this bubble, which is also weird.
It also is an explanation for why Michelson-Morley type experiments have supposedly come up empty, in that they've been looking for the orbital speed, at least, of the Earth. But
well, if you look at experiments, Michelson-Morley was a very crude experiment. I mean, if you look at the data, there was only like 3 days worth of data they collected, for God's sake.
I'm just talking about the type of experiments. The repetitions have been much more sensitive and careful.
Yes, and if you talk to Dayton Miller, he would say, yes, I totally found it. I mean, it's less than what you had expected, but it was definitely there when measured across the period of years.
But if the first order
detected a specific motion of the Earth.
If the first order experiments are showing us that the velocity is only 350 meters per second because of the Earth's spinning in the bubble, then those results could be wrong, as others have claimed. The problem is you need a much more sensitive Michelson-Morley type experiment to detect that 350 meters per second velocity.
Well, actually, to be a little pedantic, it appears that you don't measure 100% of that velocity. You might measure 98% or something like that, because there does seem to be some dragging effect, very, very small, admittedly, in comparison with the dragging effect from the revolution of the Earth. Well, but I talk about this in terms of non-inertiality, and people say, oh, the speed of the revolution of the Earth is 30 kilometers per second, and it's only 350 meters per second spinning, so therefore you should get a much greater effect. But it isn't that. It's actually the relative Coriolis forces, the relative Coriolis accelerations, rather, that indicate departure from non-inertiality, and you will see that it's orders of magnitude greater in the case of spinning, the departure from non-inertiality, than it is in case of revolution. That's why we don't really sensibly measure these effects. I mean, we can measure things like turbulence of the atmosphere and the winds from the poles to the equator, and the trade winds and effects and effects of ocean currents. These can be secondary effects dependent upon the Coriolis effect owing to the Earth's spin. But I mean, the effect of the Earth's annual revolution around the sun are basically not sensibly seen in our daily life when we have fluids or atmosphere or things like that.
I mean, I would kind of agree with that. I would say that the effect of the Earth around the sun would be like the effect of the seasons of the Earth around the sun. I mean, it's kind of like space weather, that probably we're sitting in a bubble of ether, but we do get some effects that are detectable from just the outside motion. So it does have some influence, but the vast majority of the ether appears to remain stationary around the spinning Earth. So, but this is probably what Miller.
Another issue, though, Franklin, which is you're talking about this ether bubble, but most people, when they talk about ether, they are talking about some kind of universal substance, and that the Earth is moving through the ether towards the Leo constellation at some velocity. So people have different ideas about what ether means, and that's the universal substance that the Earth is passing through, or not. So you need to define these things when you talk about what you mean by ether.
Well,
I think this is more a matter of trying to make your theory match with the empirical observations, right? So we have the empirical observations. We know the motion of the Earth around the sun and the relative motion of the Earth even through the universe, based on things like looking at the CMBR and whatnot. But with that's conflicted with the actual on-Earth experiments, which show that the Earth is only rotating. That's what the empirical evidence shows. So you have to be able to take your ether theory. Now, people think ether is just something that space is made out of. Now, Harry did mention that there is space, and that's fundamental, and that there's some people, like the Apollo people, who want to put stuff into that space to give it properties, and I also agree with that. But aside from that, whether there's a bubble of it or whether there's a universal ether, which is stationary throughout the universe, is another point of debate beyond the whole question of whether there is an ether. So let's make it clear. You have the people who think that there is just space and there's genuinely nothing in there, right? That's just geometric space. That's one way. I mean, not unless you stick a particle in it, right? That's one conception of space. The other conception of space is that you have that space, but that space is filled with particles. And so I would strongly argue that there is this sea of positrons, electrons. Like, you know, Ebola is one embodiment of that, but I would strongly argue that that is incorrect. That space is not a solid crystal. That it is just more like a dipole gas, is what I would strongly argue, since I don't see any evidence, because you can get most of the effects that you need out of a dipole gas, and I need to explain, say, the magnetic field and what that is. And the Ebola can't do that. So that's a major problem with that, whereas I can say that those little dipoles, their orientation in space determines the magnetic field. So I can get the magnetic field. They can't get the magnetic field. So therefore, I would argue that their embodiment as a solid crystal is wrong. Like I said, I'm trying to just get people to, you know, take a stand and say, yes, this is right. No, that's wrong, and tell people they're wrong when they're wrong. You know, maybe that's a little bit rough, but I don't think we're going to make any progress as dissidents by just saying, oh, that could be, or that's okay, or, you know. Now, at some point, we have to, you know, give tough love and say, your theory is incomplete, doesn't make sense, and, you know, people have to challenge. You know, like you know, Harry's challenge about, you know, how does circular polarization work in satellite communications? I mean, that's totally legit, right? You got to explain that, right? I can't right now. So, like, you know, Harry's got me over a barrel on that one. So that would be an active area investigation. That's why I have these polarization filters around here that I'm playing with, because I'm trying to figure out how that works, right? Because it's not a simple ropes through fence kind of thing. That circular polarization does not lend itself to that kind of explanation.
Circular polarization comes from the quadrature of two linear polarizations.
And that means zero to me. Maybe you should try to explain that.
That's how it's used on a radio antenna. But if you go into quantum mechanics and they say the photon is circularly polarized, and then you ask yourself, okay, how does an atom create a circularly polarized wave? I don't really see how you can say that it's a combination of the two, you know, it's a phase shift of a horizontal and a vertical, and the phase is changing. But, I mean, I don't see how an atom produces that.
Yeah, I can agree with that. I don't see how it can either.
Combination of atoms.
Yeah, make sure to mute yourself if you're not talking. We're getting pretty strong echo. So someone should talk about how circular polarization works. Okay, I'll figure it out, and I'll tell you what it is next week if I manage to figure it out.
Just bring up the Wikipedia page. It's really well explained there.
No, it isn't, because they show this thing that's spinning around with waves going this way and that way, and even looking at that, I really don't get it.
They also show the two waves that was just talked about, the combination of two waves traveling together. That's where it clarifies it.
No, you got waves.
Okay, look at it and report on it next week. That's fine.
The thing with the polarization is that, you know, it can completely block, you know, the other wave that's coming in, but, you know, you can't block.
Look at it and report on it next week.
You can't block the reception of the energy.
Well, it's not really blocking, Franklin. It's just that the antenna that transmits the circular, you know, I spent some time on this, and the antenna is designed in such a way that when you design the feed, you put in a circular polarized wave into the feed of the antenna, and you do that by this phase shifting of the horizontal and the vertical. Okay, but there are other ways to create circular polarization.
Well, I'm curious about that, because, you know, I've taken apart my satellite feed And, you know, all
It's
it is like
using horizontal and vertical, not circular. But usually, if you look in there, there's a little dipole antenna in the feed. But there's a lot of different ways that the feeds work, and that's all very complicated. But my point being that the antenna has to be, the feed has to be really good, carefully designed so that you get the pure circular polarization in one direction. And then, so in effect, basically, the receive antenna is tuned to receive or adjusted to receive the polarization that the transmit antenna receives. The easier way to think about it is, the easier way to think about it is if it's horizontal and vertical, if the antennas aren't perfectly horizontal relative to each other, okay, or vertical relative to each other, you don't get the perfect polarization effect. So you get a kind of a cross polarization interference. So in satellite communications, what we do is we design the thing so that we prevent the interference from the opposite polarization from getting into the system, which means in effect, basically, it's a more of an engineering problem than anything else. Do you understand what I'm saying here?
Not at all. I think that's the engineering question that I'm interested in, because when I look at the satellite,
it's more like
not very complicated.
Another thing you can look
up. It's essentially a problem of, you know, adjusting your tolerances so that you don't get the circular, the right-hand circular and the left-hand circular feeding into each other. So you essentially, they call that polarization isolation. So in other words, you try to make your antenna such that the polarization of the transmit antenna is exactly matched to the polarization of the receive antenna. And when you do that, you can separate the right and the left and the horizontal and the vertical. Does that make sense to you?
Well, not in satellite communication, because there is no horizontal and vertical in a round satellite dish, you know.
No, you got a wrong idea there. Okay.
I mean, that's what I see. When I see a satellite dish, I see a big round dish, and I see a little receiver thing. It's perfectly round. I take off the cover. I look inside, and I see, oh, there's just a little pin sitting in the middle.
That's a vertically, either horizontally or vertical polarization.
Another thing that might be useful for understanding that is if you look up even like a three-phase power motor, you'll see how the motor will spin or one rotation or the other, depending on the order of the phases. And circular polarization in an antenna is similar to that. It's like the magnetic field is rotating within the motor, the electromagnetic field is rotating within the antenna transmission system.
Well, I think I'd like to see someone present something on satellite transmissions and how those things actually work.
Not all satellite transmissions are circularly polarized, correct, Terry? Some of them are just regularly linearly polarized. Circular polarization just enhances the feed, I think. Correct, Terry?
It used to be, originally back in the beginning, the circular polarization was preferred because the orientation of the satellite in space, in other words, they had like a linear antenna, maybe a dipole type antenna or a vertical type antenna, but the satellite would be tumbling in space and moving around, okay? And so you couldn't exactly match the antenna on the ground to the antenna on the satellite because the satellite antenna is moving around and tumbling in all these different directions. So they used circular polarization for that reason, because the circular polarization doesn't go to zero when the antenna is moving around, okay? So that's kind of how it started. And space tracking used the circular polarization. You know, you see those helical looking antennas in the old space tracking antennas, if you're familiar with what I'm talking about. And because the missile is moving around, the antenna on the missile is in different orientations relative to the antenna on the ground. And what you don't want is to get it into a null where the signal suddenly disappears. And that is avoided in circular polarization. Okay.
So that makes sense even from the standpoint of my cell phone or something like that, where I'm trying to receive a satellite signal, I don't have to worry about the orientation of my cell phone. I'm going to pick the signal up.
Correct, but you don't get, the signal isn't quite as strong. You lose signal strength, but you don't get what are called these deep nulls, where the signal disappears completely.
Correct. Okay, that makes sense that they would use that as much as possible then.
Well, that's how it started off. And then, as I was saying before earlier, Intelsat, the international system, adopted circular polarization. But in the 1970s, when they came up with domestic satellites, you know, that transmit the TV signals and that sort of thing, those used horizontal and vertical polarization. So
I mean, that allowed you to double the amount of channels you could transmit, because you could separate out into the left and right. And
correct. That's reason why. But the technology, you know, you had to have a really stable satellite platform, okay. And when they got to where they could control the what we call the attitude of the satellite. So if you can control the attitude of the satellite fairly well, so that the antenna is, you know, it's not moving around or anything, then you can match the polarization of the satellite to the antenna on the ground. And of course, you know, you have these devices where you can move the feed, you know, move the feed around so that, you know, you can match what the satellite is transmitting. So, you know, once that technology became available, then, you know, you could transmit two signals, you know, on the same frequency. And, you know, and it really just became a technological problem of making the polarization isolation good enough. So anyway, does that make sense to you, what I just said?
I can understand the horizontal and vertical polarizations. I still can't understand how circular polarizations work. You know, this is how our new modern 3D theater glasses work. They use circular polarizations because before, when they used linear polarization, when you turned your head, then the whole effect would go away because one of your eyes would just like turn black or something.
Yeah, that's just what I explained about the
circular polarization.
If the transmit antenna and the receive antenna aren't matched up, it goes away completely.
Yeah, so with the circular polarization, you can turn your head.
With circular polarization, you can move the orientation of the transmit antenna and the receive antenna, and it doesn't disappear entirely.
Yeah, because your left lens receives the counterclockwise rotating polarization, and the right lens receives the clockwise rotating location. So it doesn't really matter how you tilt your head; you're going to always be counterclockwise or clockwise.
Yeah, but what the heck does that mean? I'm pretty sure there isn't anything going clockwise or counterclockwise in those light waves.
It's basically the order of the two phases of lights that are being transmitted simultaneously. It's if you look up, like I said, three-phase motors and look at how they order, and then you also look up on Wikipedia and you pay attention to what they're talking about there, of where two phases are mixed together to give you your circular characteristic. You'll catch on to that.
Yeah, but you have to be careful because it's not really two waves combined. That's just a thought process. That's just
I'm not sure. I mean, when I did my experiments with circular polarization, you know, I found out what the circular polarizer is just a regular polarizer on one side of this glass, and on the other side is something called a quarter wave plate.
Yeah, the quarter wave plate shifts the phase by 90 degrees.
No, I'm not sure it flips the phase. I mean, I'm not even sure what you're talking about when you say phase. So you have to be careful. But so I took them apart. I took out the quarter wave plate. You know, that thing definitely does not act as a polarizer, right? This looks like a clear piece of plastic. But when I experimented with it, I found the effect appeared to be to turn the plane of polarization by 90 degrees. That seemed to be
right, but what it's doing is it's 90 degrees out of time phase.
Yeah,
but what does that mean?
It's a quarter wave cycle later. You have a polarization in the 90-degree angle, and if the wave isn't rotating by that quarter wavelength difference of distance, it will have not rotated that full 90 degrees. If it rotates less than that or more than that, it will be rejected.
Did that actually make sense to you? Because all of that just went whoosh over my head.
Yeah.
Well, that's a way of viewing it in terms of horizontal and vertical polarization, but you could also view it kind of as, you know, the antenna, the wave as it progresses, you know, these helix antennas, the wave as it progresses along the antenna is moving in time phase. So the wave as it progresses along the helix is twisting around.
But I don't see any helix. I mean, radio waves don't corkscrew. Well, maybe they do, but I don't think they do.
Well, apparently so.
See, that's the thing. I can't see a radio wave doing this. I mean, I can't see a light.
Well, go and look at the helix antennas. I mean, that's how they do the circular polarization. One way of doing it is to use a helix antenna.
Bring up
and the antenna is a helical wire, and the wave progresses along the helical wire.
Let's see. You want to bring up. Let me get this out of the way here.
Steve, while you're doing that, one might just reflect that this is where some of the arguments about transverse versus longitudinal waves get a bit confused, because if you consider the Poynting vector, which is basically the cross product of the electric field and the magnetic field, that's the way the energy is actually being transferred, and that is you know, determined by the motion and the polarization. You see it there.
Okay, so this is a circular polarization on Wiki. Now we have this picture over here on the right-hand side, which just makes zero sense.
Go down farther, Franklin. That's not clear. That's not the clear one. Farther down, you'll find better images to explain it better.
Is that any better? I don't think so.
Keep going. Keep going. You're getting there. It's getting closer now. There's some dynamic GIFs, I think, in there too that help explain it.
Nope.
I don't see them. I haven't seen them. We haven't gone by them. We must be looking at different.
That's the bottom. That's the bottom.
Right.
You always show this crazy curlicue, you know, picture here.
I mean, look, I'm sure I was looking at Wikipedia there, so I can circle it.
Well,
let me see if I can find the other page I was looking at.
You know, this is like the problem with the mainstream. Is like, sure, if you accept all this, sure, that explains it. So you got a left one, you got a right one. And it's like, okay, but how does that make any physical sense?
No, I agree. This is a very poor representation of it here.
What does that mean? What?
Let me see. I thought I was looking at this page, but it looks to me like that's not the one. Let me see if I can find it, and I'll let you know what the address is in the notes.
It means that the electric field and the magnetic field vector are twirling in space as they moves in one direction. So depending upon how you define the direction in which the wave is moving, which is important to define whether it's left or right. Okay, basically the electric field and the magnetic field are twirling as it progresses along through space. And that doesn't really help you at all, does it?
No, I mean, I'm looking at these are the satellite dish thingies that we get to receive our satellite TV.
The dish has nothing to do with, you know, the polarization takes place in the feed, not in the dish. The dish is just a
feed. What I want to know is how these feeds work, right? Satellite dish.
It's basically an antenna that sits up in the feed. There's a little antenna up there that transmits the signal towards the dish, and then the dish reflects it outward.
So we've got feed horns, right? We've got these things.
Yes. That's what's actually transmitting the signal.
So you look at this thing here and what's inside of it, and, you know, that looks like there's just like a pin on one side, and I don't know what the heck's on the other side here. Let me see, I had a little bit better picture here. It's like, what in there
is
doing the job?
Well, that's not so easy to explain because you have different modes, different types of waveguides. You have different modes in waveguide, and not, what they're doing in effect basically is you introduce a signal into a waveguide, okay, which is essentially this little pin thing that introduces the signal, okay, is really the antenna. And then that signal gets introduced into the waveguide, which basically guides the wave or transmits the wave or propagates the wave, whatever you want. And down the waveguide, okay, and then at the feed horn, the wave is allowed to expand outward to reflect off of the reflector, which then reflects it in the opposite direction. But the design of all this stuff is very complicated, believe me. And to explain it to somebody that doesn't know about how all this stuff works is extremely difficult. So,
well, that's why I think it's important for us to understand that, because this is a very practical application, and if we could really understand why things work better than others, then we might actually be able to say something about what this radio wave physically is.
Well, the problem is, and this goes to what Bob was talking about with Weber electrodynamics. The problem is that all of the technology and engineering that goes into modern, communications equipment and everything that we're using today, that's all based on Maxwellian electrodynamics. And so all of this technology that's been built is really based on the solution of Maxwell's equations. So that's all Maxwell's equations. So to talk about a different type of electromagnetic theory is just basically, you're just starting from scratch. You would have to re-explain how all of this technology works based on another type of theory. And that's very difficult to do. I mean, basically Maxwell, all these feed waveguides and antenna theory and all that is based on the Maxwellian concept of electric and magnetic fields.
Well, Maxwellian, I think that it explains very well the empirical results, just like Newton's law explains gravity very well. I mean, engineering-wise, we can build things so that launch satellites and whatnot, but it doesn't really say how the thing actually works, right? So would that be the same case with all this antenna design, that we know empirically how everything works, but have no idea how it works?
Well, yeah, you could sort of argue that. The real problem with antennas, and and I've tried to make this point clear, and that is that when we're talking about microwave antennas, okay, you're pretty clear into the area where you're not talking about electrons anymore, okay? You're not really talking about electrons creating electromagnetic waves. It's, that's not the way the theory is done. It's pure manipulation of electromagnetic waves, okay? When you get down to the explanation about how your computer works, there's a completely different theory there. There you talk about electrons moving around in wires and doing things in semiconductors, and that's a completely different type of theory. And unfortunately, there's no, the models are kind of inconsistent. So in Bob Gray's thing where he's talking about electrons moving around and exerting forces on other electrons, that's a completely different realm of thought from what is happening in terms of radio waves and transmitting microwave signals. Do you understand what I'm trying to say here?
Yeah, that's what I was trying to tell them, that it's like, yeah, that's definitely longitudinal, but that's not what we normally associate with radio waves. You're just measuring the effect of the electrostatic field varying over time, but we don't consider that to be a radio wave. I don't think. I mean, definitely that happens.
Well,
whatever that is, as not a radio wave.
the bottom line is that when you're talking about radio waves, you have to have a dipole, either a magnetic dipole or an electric dipole, to really talk about, in terms of the modern theory, to talk about how a radio wave is produced. You can't talk about, an electrons and a segment of the wire moving around. That doesn't really, that's problematic in my opinion. But anyway, this gets into a lot of technical details.
Does anyone talk about photons when they're talking about microwave communications?
No.
So where's the transition? Where does a radio wave turn into a photon particle?
Well, if you're talking to me, an electrical engineer, I'd say there's no such thing as a photon.
Well, I agree, but
the photon, comes out of the quantum physics, where Einstein said, well, there's this thing called a photon that carries momentum. So the issue is that it's kind of hard to conceive how an electromagnetic wave moving through an ether carries momentum. What's this momentum thing that's supposed to be carried by the wave? And if you go to the photon concept, the photon, while it doesn't have any mass, it's supposed to have momentum. So, that kind of is a strange concept. But what a photon does is sort of allow you to talk about a wave, electromagnetic wave, carrying momentum. But if you think about it, a wave really can't carry momentum because it's moving through a medium. And so it's not really a mass of anything.
Well,
so how can something that has no mass carry momentum? Now,
it's transferring energy.
Right. But the experiments all are pretty clear that when you get to the higher frequencies, up to X-rays and gamma rays, and in that region, that you can model the electromagnetic wave as having a momentum, because the momentum needs to be conserved in these Compton effect experiments. So that's really another conundrum about electromagnetic theory, and a problem for ether theories, because then you have to have a way of how do you explain momentum being carried by an electromagnetic wave when a wave doesn't really have momentum?
Well, the wave front itself definitely has momentum. If you've got a wave in water and you've got a bob, the bob is moving up and down. That bob has momentum, certainly. So
yeah, but it's not in the direction of the wave. That's the problem.
Well, it can be in the case of like a sound wave, and you've got a speaker, it's moving in and out. And if you have a microphone, you can see that it also physically moves in and out. So there's definitely...
But the problem with the longitudinal wave is that the moving in and moving out cancel each other out. So you have a net zero momentum.
Yeah, net zero, but at every moment in time, the momentum is not zero.
Well, I'm just saying that's a problem. In my view, that's a problem for ether theories to deal with.
Maybe the problem is the...
That's not a problem, right? It's like, yeah, you can transfer energy. The medium just drags whatever along, and you get transfer of energy and momentum that way.
Maybe the problem is the Compton interpretation of what the experiments are showing.
That's possible, but I just sort of explained to you basically what the mainstream view is, and so the photon is kind of a way of the particle idea allows you to sort of say, well, electromagnetic wave has momentum, but as I pointed out, you sort of have the strange notion of how is it that something has no mass carries momentum, and a photon supposedly has no mass, but it has momentum. So to me, it's all strange.
Well, not quite, Harry. It has momentum, and it therefore has mass. You just divide by the speed of light. what is more precise to say is that according to the mainstream, the photon does not have any rest mass. It has zero rest mass, but when it's actually moving at the speed of light, there is a mass which is calculable. So it does have mass. The other thing, just while I have the floor, if I just mention Franklin, just getting back to circular polarization for the moment, it might be useful to bear in mind that the most general type of polarization is elliptical polarization. This is where the axial ratio, I think it's called, between the orthogonal components can be anything. Now, when that ratio is 1, is unity, you get circular polarization. It's a special case. And I think when it's infinite, you get linear polarization.
Correct.
Okay.
No, I'm showing a picture of one of these satellite feed horns here. This is very typical for your commercial satellite service. And you can see the feed horn is just this, it's just got some grooves in the top, and there's just like a pin in the middle. It's like, how is this actually even a radio wave receiver? Looks more like a telescope.
Yeah. Well, you know, looks like you got some quarter wave things going on there in the feed, and who knows what they're for. They may be, you know, you have beam forming that goes on in the feed where it, you know, you want to have a radiation pattern that doesn't spill over the dish, so to speak. And so you sort of try to adjust the beam that comes out of the feed horn so that it fills up the aperture of the antenna of the reflector, but doesn't spill over the sides. So, you know, you've got, you know, this sort of thing's very complicated. I mean, you know, I don't even know what this particular device does, so I can only speculate. And it's a circular, okay, looks like it's a circular feed. So, you know, you've got a different kind of mode going on in the feed horn than you do in ones that are rectangular waveguides. So I don't know what's going on in here. It may be that it's circular polarized, and which I don't know. I really don't know. So we can't really answer your question, Franklin.
All right, I'm just pointing out this is how this works. Is a complete bit of black magic.
Well, if you want to go to school and study RF engineering, and you know, probably take you 3 or 4 years to learn it.
And then I would probably only learn how to make it practically work, not what makes it work.
Well, nowadays people use computer programs, so you know.
Or maybe
all
this
you have
thing
to do is learn how the computer learn how to program the computer.
I mean, a lot of the engineering stuff still might be rule of thumb. It just out of 10,000 million designs, this is the one that happens to work the best, right? And they may have no idea why.
Well, not knowing what it's for, what kind of an antenna, what kind of a satellite it's being used with. It's, you know, I don't, you know, but you know, different satellites have different, you know, one company has a satellite and they design their satellite to do certain things, you know, uses a certain type of polarization, uses a certain frequency band, you know, and who knows, you know, that was one of the things when I worked in the industry, you know, you always were trying to figure out a way to best the other guy and, you know, that sort of thing. So who knows? You'd have to really dig into the details of it.
I guess. Okay, well, enough of that then. A complete mystery, perhaps. But, you know, it is interesting, you know, how in the world this whole circular polarization thing works is still a mystery. And it's true that would be a challenge to try and explain what on earth, but I only have to explain the experiments, because you would find that I would say that in the transmission of the electromagnetic field is that there is actually no electric and no magnetic component involved at all at any time. So not only is it a longitudinal wave, but it's actually just a physical pressure wave. That's the only thing that's actually changing, would be the pressure of the ether particles, whatever they may be, which in my case would just be positron, electron, C. That's what but that would be on me to explain, then how can they design an antenna that can separate out the right-hand circular and the left-hand circular wave, since I can understand linear polarizations, but circular things, I'm pretty sure, though, there's nothing going left and right. Not unless I can conclude that there is something going right and left, and then that just absolutely doesn't fit into my conceptions of how ether space works. So it's probably important for me to take a look at that, because that could make or break a theory.
Well, I think the bottom line is that nobody can really, I'm pretty sure that, if you went to electrical engineers and physicists, you probably find out that they can't talk to each other to answer this question. But I don't think there's anybody who can tell you with any certainty exactly how a radio wave works or anything like that, and what an electric field is and what a magnetic field is. And that's why people are talking about all these different kinds of ether theories, because you can have lots of different interpretations about what an electromagnetic field is, what a magnetic field is, and all, there's lots of different opinions about it that you can have. So depending upon your opinion, you can make your ether theory fit that opinion. And then somebody like me can come along and say, well, I disagree with that because your interpretation of what an electric and magnetic field is and how radiation works is completely wrong. Right?
We need to first establish whether there is an ether or not. I mean, the whole problem is when relativity came along, because of the null results of Marcus and Morley.
Find it. We totally need to find it.
It's there. It's been found.
Yeah, but we need to have a nice
experimenters
experiment.
Excuse me. The experimenters that have found it ignore it because they're looking for Lorentz invariance violations, like Brier and Hall. It found the 350 meters per second effect, but they claimed it was only noise, systematic error.
I don't think finding motion through the ether is actually evidence for the ether. Really, you're going to find the ether.
Well, that's what Lorentz and all.
Physical.
That's why they rejected ether.
Finding ether, not an effect of the ether, right?
Well,
that's why they rejected ether in the 1800s. Was
you want to try to find it? You want to try to find an ether by grabbing a part of the ether and looking at it. The problem with it is that ether doesn't come apart. It's not a piece.
Well, first
ether can come apart in my theory. The ether, or in Pola, the ether can definitely come apart in their theory. In fact, it's integral to explaining how pair production and annihilation work.
No, that's just the way. That's just the pattern. That's the patterns within the ether. The ether carrier is the energy carrier itself, and the energy carrier itself cannot be disassembled. It's not a piece. It's a singularity.
Oh no, the ether carrier can definitely be taken apart in, say, Epola theory.
And that's why you think you can take a piece of ether and look at it, because you think it can be taken it can be made into pieces.
Yes, and there's a hope. There's an experimental hope. See, the problem is if your ether is made out of these pieces that can't be examined, then there's absolutely no hope of ever finding it, right? There's no hope of finding your ether. It's impossible.
It's not made out of, that's just it. It's not made out of pieces. It is a field. It's continuum. It's continuous. It's tensionable. It's stretchable, but it's not. There's no pieces to it, so you can't look at it and say, "Oh, this."
Never find it. If you can't manipulate it, then no one has any reason to believe it exists.
The waves are moving through it. The electromagnetic waves are moving through it. The gravitational waves are moving through it. It's the substrate which carries those waves. You can't take the substrate apart because it's not made of pieces, and you're trying to take it apart and look at a piece of it and say, there, I found it because I've got a piece of it. You can't have a piece of it. It won't come apart. It's the carrier.
Yeah, that would be the problem with your theory, and that it can never be found.
That's not a problem with it.
A lot of dissident theories are they base it on things that can never be found.
No, you're not saying it can't be found. The characteristics of it have to be there in order to carry the waves. It's like you can't have.
Well, once again, in order
you can't
to
have nothing
something,
carry. You can't have nothing carry waves, which you well say. You can't.
No,
have
very important.
There has to be there by virtue of the fact that the
No,
wave.
No. Very important. In order to define and find the ether, you have to find it of its own physical nature, not defined in terms of the actions or observed actions that it causes, right?
No,
Just
it's
finding what
physical
it causes.
nature. Its physical nature is the ability to carry waves. It is.
I think one of the challenges.
Everybody knows that. You can't say that.
On etherists would be to endeavor to isolate in a flask or something the system, evacuated of ether, just like we can do with air, and then we can find that we can ring a bell within this flask and it doesn't transmit sound waves.
Exactly.
Now, if we get rid of ether from a little flask and make it strictly vacuum, and then indicate that it was impossible to transmit electromagnetic radiation through that, that would sort of be pretty convincing. Now, I think it's a very hard thing to do, but I admit that it is a challenge.
It is a challenge, but the point is that you cannot claim you found the ether based on existing experiments. Now, the experiment that Ian just mentioned would be an example of an experiment that has not been done, which would be predicted, right? But you can't say there's an ether because we have observed radio waves. I mean, that's obvious that there's radio waves, but it's completely not obvious that there's a medium responsible for that. Right? So you cannot claim any known property, observed property of space as being of any kind of evidence for an ether on its own. You know, not unless your ether predicts those specific properties. You know, like the Ebola predicts the specific properties of the speed of light, right? So that's legit, right? But you can't say that the ether, my attentionable ether, must exist because we see the existence of radio waves.
Yeah,
well, I mean, not unless it's something very particular.
The Ebola is an artificial construct with specifically chosen distances and specifically chosen forces between those distances to emulate the impedance of space. It's not something you can detect either. If you want to find out whether there's ether or not, then you have to look at, well, can energy, like Ian says, can energy be transmitted through it? Energy can be transmitted through a vacuum, so there's something there. If you want to go to where there's no possibility of transmitting energy through it, you have to go to the center of a black hole, and we can't create centers of black holes. If you want to see where there's a possibility of no ether being transmitted through it, you have to go to the absolute smallest center of an atomic particle, and there may be a point there where energy cannot be transmitted through it, but it can always, if you have a wave that's wide enough, it can always go around it. But if you get a wave that's small enough, it won't be able to go through it. Just like if you have a light wave go into a black hole, it can't go through it because it's smaller than the diameter of the nothingness that's in the middle of a black hole, potentially nothingness. And I say that because there's a possibility that light slows down as it enters a black hole, and it may slow down to the point where it just doesn't come out the other side, but it doesn't mean it didn't disappear. It disappeared into the lack of ether. So ether is the carrier, and it can't be taken apart.
Oh, sure, it can be taken apart. It's the only way it can be found. If it can be taken apart.
That's why you think you have particulate ether, because your ether is particulate. Even
That's
Einstein.
right. I think it's more congruent with the idea that that can't be taken apart, because I think
even Einstein said
experiments say that we can take it apart.
We cannot think of it as normal media.
And Einstein is completely wrong.
It has parts.
I'm not afraid to say Einstein is wrong when he said it wasn't particulate. Wrong, totally wrong. All the boneheaded things he ever said, that would have been the most boneheaded thing Einstein ever said.
And that's the one thing that's going to ever keep you from understanding it, is because you don't understand that it can't be particulate. It
No,
can't
it's
be
totally got to be particulate. That concept is just utterly wrong.
Okay, all right. We're of a different opinion.
That's right, and it's okay.
Can't really agree, huh?
But the thing is
the problem, Franklin.
Is that my theories, they start out with a particle, which is the electron and positron.
Where'd the particle come from?
An unreasonable
Where'd
start.
the particle come from? What's it made of?
We don't have to say what it's made of, because experimentally,
I have to say what this ether carrier is made of, and I just said it's made of continuum. It's continuously
Yeah, but you don't know it's not related to anything we've experimentally found. See, I have the advantage.
It is related to absolutely everything that's continually found, because what's continually found is connection between everything. Nothing is disconnected. One thing always.
What does that connection, right?
Connected through
blaming it on a mysterious ether that can't be taken apart has no relationship to electrons or positrons or any other matter that we know of. So that's a really bad start.
If it could be taken apart, there would be no possibility of anything communicating with anything. Because no matter whether you take how far you take it apart, there has to be the ability for it to communicate to another portion of it, and the only way for that to happen is for it to be a continuum.
Yeah, and it's a continuous sea of particles, right? So that makes sense. I can explain that.
Between the particles, there has to be something to connect them to pull, so that you can have a tension between them. And
you've
that means it has to be an ether between
particles. They're all interacting. Of course, you've got a tension between them.
What's it in? What's that tension in?
That tension is called just like the air in this room. That's
well, yeah. So that is the ether. Between the particles is more ether then.
No, there's no ether between the particles. I've had the discussion before. I said there's geometric space. Now, as Ian mentioned, according to us particle theorists, ether theorists, it should theoretically be possible to create a region of space which is actually free of the actual matter particles. And then you would be able to see that nothing could be transmitted through it. That it would be like a completely blank, nothing could be transmitted through that ether vacuum, right? Now that's an experiment. Now, if you could do that, that would prove the existence of an ether, right?
And
that in fact, however you did it, it was particulate.
You can't take apart something that can't be taken apart.
You can take apart the ether, according to E-Pola and my theory. You take apart the positron electron, and you will see a positron electron pop out of the middle of apparently vacuum space.
I believe Glenn Baxter would have disagreed with you that you can't take it apart.
Well, I'm sure this is the point. Like I said, I think as dissidents, we need to state a strong stance on what we believe in, right?
Exactly, and I just did.
Cornelius, you're wrong, okay? Or you can say, Franklin, you're wrong, and give, the specific reasons why.
I just gave you there has to be a communication through everything in order to detect that an ether exists.
I'm not arguing that. I'm just saying it's
nothing can move through the ether. If there's nothing that can move, if that's how you detect ether, is because no energy can transmit through it or no energy can be reflected off of it, then basically you can't detect that, because that's the only way you can detect things is by how they interact.
No, you can detect things. You can detect specific particles. You can detect electrons. You can detect positrons. And you can detect kicking those positrons and electrons out of the ether, because the ether is made out of positrons and electrons. These are things we've actually already observed and are perfectly consistent.
But you have to detect what's causing the attraction or the repulsion between those electrons and the positrons. What is carrying that attraction or repulsion?
Once again, the ether sea is carrying those forces as waves.
You took the ether apart. If it's apart,
yeah, you can take the ether apart. There's nothing wrong with taking the ether apart. The ether is composed of positrons and electrons, according to
Franklin,
Pola and my theory.
Franklin, Bob Gray here. I'm a little uncomfortable with, I'm going to say this badly, the aggressiveness with which you're saying we have to, as dissident scientists, come forward and assert something right or something wrong.
Yes, that's what I'm totally trying to tell you.
Yeah,
I
I'm a
know
little
you're
uncomfortable.
with it, but I think we need to do that. Because
I'm a little
otherwise we end up in-
uncomfortable. I'm uncomfortable with that because I think anyone should be able to say, I am starting with these axioms or these postulates, and from that, I am arguing in a logical way to come to a particular conclusion. I can see where you could say the logic flow doesn't follow to your conclusion, but I don't see how we should aggressively assert somebody's right or wrong when they say, I'm going to start here with these postulates, which I don't know if they're right or wrong, but from there argue in a logical way to a conclusion. It's only that logical
let me say this
to conclusion, which I think you could say right or wrong, not the initial postulates.
No, this is actually the root of the problem. Because from your postulates, your entire, actually doesn't matter what the scope of your logic is based on your postulates are, because you can always pick some postulates to make any crazy theory work, right? This is true. And as Bill Lucas says, that as your postulates fall, your entire theory falls. Dissidents are often building castles in the air. And I think we need to aggressively, in order to get some progress, stop people from building castles in the air and agree on the things which we know are really true. So you're not, by allowing people to pick arbitrary postulates, we're allowing them to stay in their unicorn rainbow land and not getting anywhere, right? So when people start off with their postulates of, the ether is this tensionable medium, whatever that is, that we can never find, I think we need to aggressively either establish, what that is, how can we experimentally detect its difference, and you do that by, if you have this, that you have to be able to predict certain things that you would normally expect, but if theories like that start out like that with postulates like that, fundamentally, even on a theoretical basis, can't be shown to be true. See, that's a big problem. So, I can understand people not being comfortable, and I've been with the CNPS NPA for a long time, and I see the same thing happening over and over and over again, that people should be engaging in this, yes, you're wrong, and be afraid, and not be afraid to say that. So that,
but not at the postulates, at the conclusions, when you take those conclusions and compare them to experimental evidence.
Yeah, but the conclusions, like I say, your theory falls as of the postulates. That I've seen number of things where, it appears to work, but your postulate essentially says, I have a little green fairy, and this little green fairy does everything. And you can never find my little green fairy, and there's no way to experimentally show that my little green fairy exists.
Well,
and I think you're just fooling yourself.
I have a little green fairy, and it's called gravity, and exists everywhere, and there's nowhere where you can not find it.
Well, then you got to tell me what that is, how it relates.
Gravity is attraction. Attraction is attention. And so there's no place you cannot find tension. So that's the fundamental postulate that everything is built from.
Well, I'm sure there's tension everywhere. I mean, I wouldn't disagree. The only thing I'm disagreeing is that your tension is
between everything.
Particulate seeds.
There's no place that things are disconnected from gravity. So when you explain gravity first, you can build from there. Gravity is the most fundamental there is.
Yeah, and gravity, in my theory, is just the electrostatic. It's just an aspect.
No, because now you've got the electrostatic. You don't have
electrostatic is just a wave in the ether.
Electrostatic to have gravity.
Yes, you have to have electrostatic to have gravity. Yes, this is true. And there's a lot of evidence to suggest that it is.
In order to have electrostatic, you have to have particles. And you haven't even established particles yet. Because
Well, I
gravity.
established the particle as the positron, the electron. We know those things exist. There's no question about that. We know what their properties are. There's no question about that. So if I start a theory out postulating the existence of electrons, that's not even a postulate. I mean, that is hard scientific fact.
But you took away the mass from the positron electron, and you made them a positive electron that's invisible, that has no mass.
No, it does have mass. Of course, it has the mass of a positron and electron, of course. So, who said there was no mass?
But you could call the electron,
There's mass, then
call
you,
the electron a fairy, right?
Well, we could, except that
Because you don't really know what it is.
Before it exists. See, that's why my electron is not a fairy. The electron is hard scientific fact.
If there's a
Electron
positive
exists.
electron C, a vacuum would have mass.
Yes, and a vacuum does in fact have mass.
No, I
Some
can't
people
wait.
have
It doesn't
calculated
have
it to be like
gravitational mass.
5 million
Doesn't
times
have-
the mass of steel.
It doesn't have gravitational mass. It doesn't have inertial mass. It does not have mass. It has the potential of steel to carry tension, but it doesn't have mass. It doesn't have weight. It doesn't have gravity.
Why would you say any of that?
Because
Of course it has
gravity,
gravity.
because mass
Of course
is
it has mass.
Mass is associated with inertia, and mass is associated with gravity, and that's how we determine whether there's mass or not.
Well, inertia is actually determined by the activity of particles moving through the ether, which is just the C.
Inertia is
It
determined
itself,
by the amount
it
of mass.
itself determines, I would say it itself determines inertia. But I'm just saying that there's some hope that if the ether is made out of some recognizable particle, that you're better off, right? So if the ether was made out of protons, that you would be better off. Dirac thought that space was made out of a sea of, electrons or something. You would be
If
better
it was
off.
made out of protons, I have to explain how protons can come and go. If it's made out of
Yes,
electrons
that's
and
the problem.
positrons, I have to explain how electrons and positrons can come and go.
That's
I can
why it's
explain
kind of
how
hard.
electrons and positrons come and go as patterns of tension energy within attentionable media. And I have. And I have explained how mass comes and goes with, and neutrons come and go within attentionable media.
The problem
I've even given you experiments to show it.
You've explained nothing.
Experiments to show it.
If you have not explained what your tensible medium is, you've explained nothing. Zero.
Tensionable media is a
Zero.
tensionable media. It carries tension. I gave you the example of the surface tension in water. There's a tension between the particles.
Yes,
You
and
get
we know that those are
particles,
not particulate mediums.
You get rid. That's because that's how we see it. It's the only way we can see it is if there's a particle that's
It's the only
affected by
way that
the
it's
tension.
logical is if it's made out of particulate mediums. Would be my argument. So no matter what castle in the sky you have built, right?
Well,
It has to come down to your postulates.
you need a medium that's mechanical in order to be able to for our human senses to see it. You would not know that radio waves are there if you didn't have our equipment to tell you that they were there.
So?
So what I'm
Got it.
saying is, it's
I
there.
mean, there's invisible light. Does that mean that there's no light?
The media is carrying those radio waves, but you can't see them. You can't see that media.
Only due to our limited ability. I mean, there are other creatures that can see in the infrared.
We also have a limited ability to see the media that's carrying gravity.
But that has nothing to do with the medium. I mean, if I claim the medium
Certainly. How does gravity propagate?
as a wave,
Through
point
what?
blank,
Through an invisible
positron,
media.
electron, C. That's what.
No, positive electron C's are visible. They have mass.
Yes, and we can't see them. We can eject the positron, electron out of that C easily.
There's no
Routinely.
positive electrons between here and the moon.
Absolutely, we're just completely filled.
Go through it. There's no mass between here and the moon, or we wouldn't be moving.
Why would that have anything to do with it? Why? Why would it have anything?
Because
What's the
mass inhibits motion. You have to impart energy upon mass to get it to move. But
And
wave,
why do you have to impart energy upon mass to get it to move? As if there was something in the way, right? That something in the way is the positron-electron seed.
There's nothing in the way of a wave moving through a block of steel. It can move through a steel easier than it can move through air. It can move through a solid.
You keep on changing the subject here, man. You keep on changing the subject.
I'm not saying the subject is all connected. I'm just saying it's basically there's a continuum.
And I say it's also continuum. I'm not saying that it's not. I'm saying not only is there a continuum, but it's made out of a specific substance that we can actually find.
Now, substances are nothing more than wave patterns within that continuous medium.
And I would totally agree with that. I just had I'm taking a very strong stance in my emails that there's any conception that, say, an electron is made out of a wave or is in any kind of congealation of space is another thing that I just think is totally wrong.
Well, I've seen your stance, and I think everybody's seen your stance by now.
Yeah, and I'm saying I'm saying that in this talk, I'm just taking just this opinion here, which is that we need to take that stronger stand.
Well, Franklin, can I ask a question here at this point? I'm sure there are lots of other people. We're getting towards the end of the time.
Yep.
Why do you think this is more important? My view on dissidents, and I find this phenomenon not only in dissident science, but in other forums where you have discussion, and that is that it's generally more likely that people will disagree than agree. I rarely find hardly anybody that agrees in discussion forums. My question is, why don't we focus on why mainstream is wrong rather than focus on my theory is right?
Because that will be the only way we will show that mainstream is wrong, and that's perfectly legitimate. In order to show mainstream is wrong, you have to show them a theory which works better. Okay?
Why?
There's no, because
why?
You're going against like 500 years of mainstream saying that this theory works.
Oh, they're going to ignore you anyway. So
abandon that.
Why shouldn't the focus be on what's wrong with what mainstream teaches rather than my theory is right?
Because that is a negative activity, right? That will never produce what we want to produce, which is the real knowledge of how the natural world works. Just saying that you're wrong is grossly insufficient to coming up with what we want, which is to figure out this is how it actually works, right? So there's really no gain in saying Einstein's wrong.
Well,
unless you have anything to show that what works
but
better.
You're never going to get anybody to agree on what your alternative is. So there's never going to be an agreement on the alternative to what mainstream says. So
well, that's why I'm saying
it's a futile activity.
I'm trying to put into your as uncomfortable, and I feel kind of uncomfortable, even as a moderator, just trying to, make such strong stances, right? Moderator is supposed to be neutral, accept everybody, everything's good, a whole liberal thing, But no, that's not getting us anywhere. All it gets us is all this continual circular arguments with nothing to grab onto, right? There's no Plymouth Rock that can say, yeah, that theory is better than this other theory.
Yeah,
right?
But the mainstream has that same problem too. The only issue is that they cover up the flaws by having a united front. And that united front is enforced by the fact that if you don't agree with what we say, we fire you.
Well, that's right. Within the dissident community, in order to make
there's no firing in the dissident community, because you're not getting paid. So
yeah, so
they have a bigger club
so
and
they're standard. So, but as long as no one's willing to take a stand and and specifically rule out theories, there's no.
Well, I think I took a stand. I don't think any of the ether theories are viable. That's my stand.
And then we should talk about that, and we should make a viable ether theory, or you convince me that it's not my ether theory is wrong. Yeah.
I don't see any viable ether theory, so I think that's a loser thing to take a stand on.
And I see a viable ether
any viable
theory.
theories at all, Harry?
Huh?
Do you see any viable theories at all?
No, not really.
Okay.
No? Okay, well, then you have no dog in this game, and maybe one of us can convince you one of these days. Although it's the end of our time here, so I have a hard stop today. But so I thank you for all of your participation. Like I said, we kind of gotten into this discussion of, ether. And really the only point that I think I was trying to make, because I am trying to take a harder stand on, people's postulates, really. And or taking a stand where people actively debate what are the wrong or right points on your theory, rather than just, once again, spitting out what your theory is. People need to come out and say, I don't understand your theory doesn't make any sense. In order for us to make any progress, because we can't all be right, we're probably all wrong, but if we adopt, some logical standards, and I don't know what those would be, but we need to debate and clearly say something's right or something's wrong. So that's really my only point there. So that will do it for this week's episode. I think next week we have Mr. Ellis. He's going to be talking about the ionic growing sun. So I'll make an announcement on that, and don't miss that. We'll have a special speaker next week. All right.